Chapter 3 is all about looking at relationships between two quantitative variables. And so we're going to do that by examining scatter plots and then looking at things like correlation, which is a measure of how linear a data set is. And then we're going to look at things like calculating an equation for a line of best fit. So one thing that we need to be able to distinguish between is what we call explanatory and response variables. And so the explanatory variable is looking at what's going to explain or influence changes in the outcome of a study. So the outcome is going to be the response variable. And so when we graph, the response variable goes on Y, and the explanatory variable goes on X. In terms of kind of more science terms that you may have learned with response and explanatory variables, you may have done independent and dependent variables. So the response variable is dependent on the input. So this would be your dependent variable. And then your explanatory variable is your input, and that would be your independent variable. And so it's really difficult for us to say that one variable causes something else, so that your explanatory is directly causing the changes in the response variable. So that's usually the goal in a lot of studies. And if we have a really well-designed study that has some other components along with it, like it was designed well and it was replicated, those are all things that are necessary in terms of trying to establish cause and effect relationships. And we'll talk about those more in chapter 4. But just because you see a strong relationship doesn't mean that we have direct causation. And we'll talk about some things in this chapter that might also be influencing that relationship. So the graph that we're going to use in this chapter is called a scatter plot. It's the most common and useful graph to look at two quantitative variables together. And so really, you just put your explanatory variables on the x-axis, your response variables on y, and then you're going to plot your ordered pair points. One thing with a scatter plot is that you do not need to start at the origin. Because depending on your data, you might have a lot of wasted space in your graph if you try and start at 0, 0. So you're going to start at an appropriate value on x and an appropriate value on y relative to your data set. So when you go to make a scatter plot, you'll decide which variables are explanatory and which is your response. And then you label and scale your axes. So you need number values on both x and y and variable names on x and y. And then you just plot those ordered pairs. So here's an example where we're looking at a scatter plot between an individual's body weight and backpack weight. And so body weight probably explains backpack weight. So how large the individual is explaining how much they're carrying in their backpack. This is an example about hikers. So here, you're going to put body weight on x and backpack weight on y. Like I said, we do not need to start at 0. So we've got the smallest body weight is 103 pounds. So starting at 100 pounds here. And then your smallest backpack weight, it looks like, is 24. So starting at 20 here. And then you just want to be consistent within the axis. So like on the y-axis, counting by 2s, and then on the x-axis, counting by 10s. It just needs to be the same interval on each axis, but not the same for x and y together. And then you just plot those ordered pairs. So for example, this point that's outlined here is that 120-pound individual that has a 26-pound backpack. So once we have a scatter plot, we are going to be able to describe and interpret them. And so really kind of looking at the same general ideas that we had earlier this year, chapter 1, is that you're going to look for patterns and then deviations from those patterns. Now, we're not going to describe with the socks like we did for one quantitative variable, but it is kind of a similar set of guidelines. So really, you need to describe the direction, the form, and the strength of the relationship, and then any unusual observations. So an acronym for you to remember here is DUFS. So direction, unusual observations, forms, and strength. So you might be looking at this and saying, okay, I'm not really sure what you mean by direction or what you mean by form. So direction is really going to be, is it positive or negative? So what kind of trend do you have? As X increases, is Y also increasing? Or as X increases, is Y decreasing? Unusual observations, just things that don't fit the visual trend. There is no outlier check for scatter plots. Form is basically, is it linear or is it not linear? We could be a little more specific. You might look at a graph and say, this looks like it's quadratic, but we don't have to go that far. We would just say that there's a nonlinear relationship or there's a curved relationship. And then for strength, eventually we're going to have a measure numerically to measure strength. But for right now, it's just how close are the points to a line. So just a visual inspection of strength. And like I said, later we will actually calculate what's called the correlation and have a number value to go there. So here's an example again, same one. We've got body weights and backpack weight. So if we want to describe our distribution here, we definitely have a positive direction. As body weight's increasing, backpack weight is also tending to increase. And it is a linear relationship. In terms of potential unusual observations, maybe as the individuals got heavier, you had some that didn't fit the general trend as well. So kind of this person here that was 187 pounds had a lower backpack weight relative to what we would expect. So we are going to describe in sentences and in context, just like we did in chapter 1. So we've got a moderately or reasonably strong positive linear relationship between body weight and backpack weight, and then just noting that individual that has an unusually light pack for his or her weight. So here we've got the positive and negative associations kind of defined, and it is pretty wordy for positive, like above average values of one variable accompanying above average values of the other. All that positive association is really telling us is that as one variable increases, the other also increases. Negative association, again, a really wordy way of saying as one variable increases, the other decreases. So here's another example that we can go ahead and interpret by describing the DUFs. And so here we have the percent of individuals from each state taking the SAT graphed against their mean math SAT score. And so here when we go to describe, we can kind of see that it's a little bit curved. Or if I go back and take that arrow off, almost like we have a couple of clusters in the graph. Like you kind of have this cluster here where there were lower percents taking the SAT and another cluster here. So we want to make sure we include that in our description. So it is moderately strong. There is a pattern. It is negative. So as the percent increases that are taking the SAT, the average SAT scores tend to go down. And then curved relationship between the two variables. We, again, like I pointed out, there are two distinct clusters. So you kind of have this set here and this set here. And then there are a couple of unusual observations like this state here where you have about 20% taking the SAT. They had an unusually low average SAT score relative to the rest of the group. So as far as scatter plots go, you guys have a few homework problems and then an optional Khan Academy if you would like some extra practice.